All right, so number 14. All right, so let me go over the rules. If you hadn't seen them in the textbook, just to kind of reiterate everything, there are 3 scenarios that we check for in algebra when we're trying to identify the domain of a function. Okay, so first, one problem is if we have a fraction. So usually we'll write it like px, it could be some function over some other function. Okay, let me say gx, for example. It doesn't matter. Okay. When you have a rational function, if you have x in the bottom specifically, we find our domain by taking only the bottom, so g of x in this case, and setting it not equal to 0. So, for example, if I had, let's say 2x plus 4 divided by 5, okay, this would not pose a problem. There's no x in the bottom, okay, so my domain would be fine. However, if it was something different, let's say if I flip this, if I had 5 divided by 2x plus 4, okay, so the moment that I get a variable in the bottom, my domain is going to be restricted. Okay? So I take the bottom only, set it not equal to 0, and then you solve for x. So your domain will be restricted if you have a fraction, rational expression. That's case number 1. Case number 2, if you have a even root, so that's like square root, which is understood to be a 2. If you have a 4th root, 6th root, so any kind of radical that has a even root. Now, if you had a 3, 5, 7, this does not apply. Even roots only. So if you have a square root, even, and whatever's under the radical, let's say 4x minus 2, okay, whatever's under the radical, because of the even root, it has to be positive. So your domain would be restricted based on what's under the root. So you can have plus something else outside of the radical that does not affect your domain, only what's under here. This won't affect it as long as it's not a rational expression. But under the radical, it has to be positive. So you would say domain 4x minus 2 has to be greater than or equal to 0. So you cannot take the square root of a negative number, so therefore the condition, it needs to be positive, and you solve for x. So for example, in this case, you would add 2, and that would give you 4x is greater than or equal to 2. You would divide by 4, and you would get x is greater than or equal to 1/2. Okay? So on a number line, since they're greater than or equal to, let's say that this is 1/2. It would be in a bracket, square bracket, 1/2. And that would go all the way to positive infinity. So your domain would be bracket 1/2 up to positive infinity. Only those numbers would work and give you a positive value. The third case, which you won't see till later on in the semester, is a logarithm. Okay? So if we're doing log some base and some expression x minus 4, for example, whatever we're evaluating the log of, that expression has to be strictly greater than 0. Okay, so your domain is going to be whatever values, when we plug in, make this expression positive, greater than 0. So in this case, if I add 4, my domain is x has to be greater than 4. Now, when it's strictly greater than, you will use parentheses. So if I did a number line, let's say that this is 4, it would be a parenthesis, and it would go all the way to infinity. So our domain in this case would be 4 to infinity. So you will have restrictions in 3 scenarios: fraction, even root, log. If you don't have any of these present, your domain is going to be all real numbers. Okay, so that's what you're going to remember. Fraction, we have restrictions. Even root, we have restrictions. Logarithm, we have restrictions. None of these means all real numbers. Okay, so I'm going to put this to the side. We can now answer these questions. So part A. Okay, I look at this function P of t is equal to 6t plus 1. This expression doesn't have any fractions, doesn't have any even roots, doesn't have a logarithm, so my domain is all real numbers, or negative infinity to positive infinity. Okay. Part B. We have q of t equals the square root of 6t plus 1. All right, so since we have an even root, our domain is going to be restricted. We take what's under the root. It has to be greater than or equal to 0. Subtract 1. Greater than or equal to negative 1. Divide by 6. Okay, so that means negative 1 over 6 all the way to the positive infinity. So my domain, in this case, will be a square bracket because equal to negative 1 over 6 to positive infinity. Okay, infinity will always have parentheses because we never reach it. All right, C, we do have a rational expression, so we have, I'm just going to write the function down, t divided by 6t plus 1. So this time, whatever makes the bottom 0, when you have a rational expression, we set it equal to 0. Domain 6t plus 1 cannot be equal to 0, cannot divide by 0. Same process we just did over here. Subtract 1, divide by 6. We'll get that t cannot equal negative 1 over 6. Okay, so again, that's like 1 point being removed. And in interval notation, we have 2 sections. Okay, so I got the left half, negative infinity to 1 over 6, and the right half, 1/6 to positive infinity. And so we're going to input all of these in so we can see our domains in interval notation. So part 1, both parentheses, negative infinity to positive infinity. All right, part 2, we had a bracket on the left. That was negative 1 over 6. And that went all the way up to positive infinity. Okay, so that's this part right here. And then part 3, we're going to have 2 separate pieces. Negative infinity to negative 1 divided by 6. And then, where's our union at? Negative 1 over 6 to infinity.